Hello everyone, and welcome to section 7.5, where we get the chance to apply everything that we've learned about weight and balance to helicopters. Helicopters is a different animal than aircraft, and it deserves to be treated as such. So because of that, we're going to apply what we've learned and do some helicopter weight and balance and even some corresponding paperwork on an Excel spreadsheet. So I want to start off, again, why is this lesson important for becoming an aircraft maintenance technician? I'm going to read this out to you. On October 16, 2023, The Guardian put out an article about a group of sumo wrestlers that were scheduled to fly together for a flight to one of Japan's southern islands for a wrestling tournament. When the pilots were completing the weight and balance calculations with the loaded sumo wrestlers, they determined that basically the sumo wrestlers were too heavy. In order to stay within the CG limits, the CG envelope that we've talked about, they had to lose fuel, and it wouldn't have been enough fuel to get them safely to the island. So, do you know what they had to do? They had to schedule a completely different flight for just the sumo wrestlers instead of having them with regular passengers. So, in this lesson, you're going to use everything that you've learned about weight and balance, apply it to the unique rules of helicopters, and solve a weight and balance problem where you have to put a sumo wrestler on a helicopter. So let me tell you about what makes helicopter weight and balance a little different from aircraft weight and balance. The procedures are largely the same. If you think about it, you still have to account for weights, moments. There's still a CG envelope. There's still graphs you have to read. A lot of the same procedures apply. But there are two main differences. The first main difference, and I'm going to start over here, is that with with airplanes, you may remember this image from previously, we only really cared about the longitudinal axis. We didn't really care about what was going on in and out of the screen. If there were two seats or one seat here, we just assumed that it didn't affect the moment much other than just by weight. You didn't have to account for whether it was on the right side of the airplane or on the left side of the airplane. We only cared about one axis, and that was the longitudinal axis. With helicopters, we introduce a second axis. I'm going to show you this down here so you can get a better view of it. What you're going to see here, what you're going to see here is that, like with airplanes and helicopters, we also care about the longitudinal axis. We make reference to a datum. If you're forward the datum, then you're considered negative values with your arm. And if you're aft of the datum, you're considered to have a positive value. That doesn't change on the longitudinal side. In that very sense, the helicopter and the airplane are exactly alike. But we take into account a second axis, the lateral axis. And the reason why is because helicopters have a less lenient center of gravity range, so we have to account for the side weights. If you take a look at this picture, and I know it's a little fuzzy, you're going to see two guys inside of a Robinson R-22 helicopter being drawn. And if you have, what they do is they have this axis here that's the center line, and essentially on the left side of the aircraft, from the perspective of the pilots, it's negative. And on the right side of the aircraft, from the perspective of the pilot, it is positive. And that can affect it greatly. In a helicopter, what you're faced with is that if you have a really heavy person on this side and a really light person on this side, the moments could actually cause it to rotate it in that positive direction. So, again, moments, center of gravity, it's a lot more sensitive in an aircraft. And just to show you what that means, I'm going to actually adjust my screen here to give you a better idea. This right here is an excerpt taken from the type certificate data sheet of a Cessna 172S, an aircraft that we worked on previously. You're going to notice that in the normal category, a very light load, that it has a center of gravity range from 36.4 to 46.4. So that's a center of gravity range of 10 inches. So you have some wiggle room. But contrast that to what you're faced with over here, and you're left with basically about 96 to 102. That's wiggle room of about 6 inches. So more or less, you have very little wiggle room to work with. And in some conditions, you even have less than that. Like if the aircraft is heavy enough, you only really have about a 3 to 4 inch window to work with over here, and maybe about a 1 inch window to work with over here. So you have to take into account those lateral and longitudinal moments. It's super important. And that CG range is less for helicopters. It's a whole lot more sensitive. So hopefully you understand the basic concepts here. I'm going to give you a moment to answer a couple quiz questions just to make sure you have a good understanding of this. And then we're going to jump into another video where we do a sample problem. And then we'll jump into another video where you'll do a lab. So I hope you enjoy the rest of this lesson. We'll see you in the next video.